Dear student, now we can see a covalent bond is formed by different elements, different atoms. Okay, let us see in the case of hydrogen chloride. Here, hydrogen has 1 electron in the outermost shell, chlorine has 7. അല്ലേ, ഹൈഡ്രജൻ 1 ഇലക്ട്രോൺ ആണ് ഉള്ളത്, ക്ലോറിന് 7 ഇലക്ട്രോൺ. 1 ഇലക്ട്രോൺ കിട്ടണം ഫോർ വാട്ട്? സ്റ്റെബിലിറ്റി. So what they do? They share each other. Look at here. Hydrogen and chlorine. They pair, sharing a pair of electron here. Like that, a compound is formed. But in the case of carbon tetrachloride, that is 4 chlorine atom reacts with carbon for what? Getting stability. How many electrons are there in the case of carbon in the outermost shell? It is 4. Why? Because the valency of carbon is 4. Atomic number of carbon is 6, that is 2, 4. So 4 more electron is needed to get stability. So valency is 4. In that case, how carbon tetrachloride structure is formed? Look at here. See, carbon tetrachloride, CCl4. Carbon, 4 chlorine atom, 1 chlorine, another chlorine, another chlorine, another chlorine. By pairing electron here, one electron is for carbon and one is chlorine's electron. See, this is the structure of carbon tetrachloride. So try to write this one. It may ask in your questions, exams. Okay. Now see another term, electronegativity. Electronegativity means it is the attraction between the electrons when a covalent bond is formed. By this electron attraction, if it is more than 1.7, ionic bond is formed. If it is less than 1.7, a covalent bond is formed. That is the difference between electronegativities of the two atoms. An American scientist, Linus Pauling, give a electronegativity scale between 0 and 4, and he gives an idea about calculating the electronegativities and forming the ionic or covalent bond. And here let us see an example of sodium chloride. The electronegativity of sodium is 0.93 and for chlorine 3.16. So what will be the difference? .23. It is higher than 1.7, so the compound is ionic. Let us take another case of HCl. What is the electronegativity of hydrogen? It is 2.20. For chlorine, 3.16. See here, it is less than 1.7. So, in the case of hydrogen chloride, a covalent bond is formed. Like HCl, HBr, HF, like all these cases, covalent bond is formed by looking the electronegativity. Now, we can move in another term, polar compounds or polar nature. See, what is polar nature? In a covalent bond, if two electronegativities of atoms are same, they attract equally. But in the case of different atoms, the attraction will be different. That is, in the case of HCl, electronegativity of hydrogen and chlorine is different. So, chlorine attracts more electron to side of chlorine to the nucleus, so it gets slightly negative charge. That little negative charge is called delta negative. And hydrogen, it loses its attraction power, so it gets delta positive, usually written in this manner, delta positive and delta negative. So this type of compound, covalent compounds, are called polar compounds, or it show polar nature. In the case of different atoms, when covalent bond is formed having different in their electronegativity, this type of polar compounds are formed. In the case of sodium chloride, an ionic bond is formed, but in the case of wax, plastic, all these cases, covalent bond is formed and they do not conduct electricity. Okay.
Let's take a look at the molecular geometry for CCl4, carbon tetrachloride. You can see in the Lewis structure there are 4 chlorine atoms on that central carbon, and according to valence shell electron pair repulsion theory, those chlorine atoms, they're going to spread out as far away as they can from each other while still being bonded to the central carbon. When they do that, we're going to have a tetrahedral molecular geometry, and that's going to look like this. The carbon will be in black and then the chlorines are green. So you can see that they're spread out pretty much as far away from each other as they possibly can. We could also use the AXN notation to figure out the molecular geometry